got to give the people. I give the people what they want. The people what they want. Finding roots of polynomials with non-factorable quadratics. That's a lot to say. But basically what I'm saying is, what happens is after you take that first root and you divide it through, if you get a quadratic that you can't factor, well, let's find out. So write this down. Go ahead and factor this. This is a big overview that we're doing today. In other words, think of the big picture. Think of the big idea and the connections. Don't focus so much on the process. You're going to have more time to get through the process. Focus on the connections. All right, so we're going to go ahead and factor this when x plus 3 is a factor. So again, what we are accustomed to is I know that I'm going to get 3 factors because it's a third degree polynomial, right? So I get like x plus 3, x minus something, and x plus something else. I don't know what those are going to be. And then we would use these factors to find the roots, right? We're looking for the roots. We factor it because we can use the factors to help us find the roots. So that's what we're going to try to do. All right. So we're going to go about doing that in the same way that we have been. We're going to say, okay, well, we're going to have to divide this thing by x plus 3. So here's x, here's 3, here's x cubed, here's 15. This has to be x squared. You should finish this on your own. 3x squared. This has to be a 5 because that's a 15. These need to add up to what? X squared's negative 9. So this has to be negative 12 x squared, which makes this a minus 12, I believe. Yeah, minus 12x. Right, this becomes negative, what is this? 36x. And I'm just checking this through to make sure it works. Oh yeah, 5, right? Perfect. All right, so this worked. So we're doing pretty good. Everything feels good so far. So far we know that, well, y equals x plus 3 times x squared minus 12x plus 5. And what kind of polynomial is this? We should recognize that it is a quadratic. So cool. We know how to factor quadratics, so we're just going to try to keep it going, and we're going to try to factor this quadratic. Why don't you factor that quadratic right now? Pause it. Factor it. Cool. You did that, and you should have found out something really weird. So you're like, okay, well, let me factor this quadratic. Boom, boom, boom. Here's x squared. Here's 5. I know that they should add to something. What should they add up to? They should add to negative 12, and they should multiply to 5. Okay, I'm feeling pretty good. I need 2 numbers that add to negative 12 and multiply to 5. Well, the only numbers that multiply to 5 is 1 times 5. And there is no way that those are going to add to negative 12. So I'm in a quandary. Doesn't work. It is impossible. So what do I need to do? What do I do? What do I do? What do I do? I can't factor this quadratic. Can't do it. All right, so what do I do if I cannot factor a quadratic? Well, I can use the quadratic formula to find the roots of any quadratic, even if it cannot be factored using the area model. I can always use the quadratic formula. It is always going to work no matter what. Factoring doesn't always work. The quadratic formula will always work. It's not always faster, but it will always work. So you're asking yourself, well, what is this quadratic formula that you speak of, Mr. Bass? Well, it is this one right over here. Boom. Negative b plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula. But now the important piece that we need to know is that that quadratic formula gives me roots or x-intercepts. It does not give me factors. It takes me straight to the roots, straight to the x-intercepts, not factors, okay? And again, we're going to keep talking about this, so don't trip out. So then, the other piece you need to know is, okay, well, I see this crazy-ass equation. What the heck are A, B, and C? Where are those coming from? They come from your quadratic trinomial, right? So, A is the coefficient that's in front of the x squared terms. B is the coefficient that's in front of the x term. And C is the constant that's on its own, okay? It doesn't have any x's with it, all right? So again, what I want you to recognize is that this is an introduction. So please try to focus on the big picture right now. Don't focus on the minutia. Focus on the big ideas. What are we actually doing here? All right? So let's go back to our question that we had before. We had this. Let me make sure that's in the picture. We had this quadratic trinomial that we could not factor doing the area model. So we're going to factor it using the quadratic formula. And remember, because we started with this big old thing, and we knew one factor was here, and we know that this quadratic should help me get the other two factors, which are going to ultimately help me get the other two roots, except for the fact that I can't find the other two factors of this using the area model. So I'm going to go straight to the roots using the quadratic formula. All right, so let's see. We need A, B, and C. So I'm going to start to plug stuff in. So we have, here we have 1x squared minus 12x plus 5, right? So A equals 1. B equals negative 12, right? And C equals 5. Now that I know those, I could plug them straight into the quadratic formula. So let's see. Negative B. So negative B is negative 12. Negative 12 is positive 12. Plus or minus the square root of, let's see, we have B squared. Negative 12 squared minus 4 times A, which is 1, times C, which is 5. Notice how I'm doing this. I'm putting everything in the parentheses. Please do that. Just trust me. It matters. It makes a difference. And this whole thing is all over 2 times A, right? Yep. 2 times A, which is 1. Now we're just going to simplify. So we're going to simplify this piece right here. It's called the discriminant. And we're going to talk more about that later, but we're going to simplify what happens under that square root sign. So negative 12 squared is negative 12 times negative 12, which is 144. Minus. Here's where people mess up. I write the minus sign, right? So I already used the minus sign. I'm going to do 4 times 1, which is 4. 4 times 5, which is 20. So this is minus 20. Over, this is 2. This is a plus minus, and this is 12, okay? So I got to here right now. There's more simplifying that I can do. So I still have 12 plus or minus the square root of 124 all over 2. Now, here's the cool part. Let me see. Does 124 have a square root? 124, the square root of that. It doesn't have an exact square root, which is why, since there is no exact square root to 124, it's like a little bit more than 11, we're just going to keep this as an answer. I don't have to simplify it anymore. So remember, this right here is actually 2 answers. And again, remind me, are these answers factors or are they roots? Hopefully you're like, oh, this one takes me straight to the roots. It gives me 2 roots, 2 x-intercepts. And you're asking me, well, why is it 2? Well, let's look at all the roots we know. We knew it had one factor of x plus 3. This was a factor. So if I wanted to find the root, I set it equal to 0. And I found out that the first root is x equals negative 3. The first root is at negative 3. But now I have another root. The second root, which comes straight from here, is 12 plus the square root of 124 over 2. That's root 1. Here's root 2. What do you think root 3 is going to be? It's going to be 12 minus the square root of 124 over 2. There are my 3 roots, okay? So when you get a quadratic that can't be factored, use the quadratic formula. The quadratic formula will take you straight to the roots. And if we look back, my question was finding the roots of a polynomial. I should have 3 roots because this was a 3rd degree polynomial. I would have had 3 factors as well. And I see my roots are right here. Let me make that a little bit bigger. So don't stress out about this. We're going to have plenty of time to work on this. We're going to be doing it for a couple of days. We're going to take it piece by piece. The next thing that we're going to do in class is just connecting all the main ideas. So don't worry if you don't know how to use the whole quadratic formula yet. We're just connecting ideas first, and then we're going to get into the actual nitty-gritty of the math a little bit later. All right, you all. Excellent work. See you later. Bass, I'm out. Deuces.